Welcome to myprojectbazaar.com. Let us see the process called an efficient automated system for detection of diabetic retinopathy from fundus images using support vector machine and Bayesian classifiers. Let us see the abstract for this process. Here, in the pre-processing method, the input image is represented in the green plane and then it is filtered using median filter for smoothing, and then it is normalized to get compensated image. After that, the transformed image is obtained by the difference between the input image and opened image. The image is then reconstructed by geodesic and threshold image is obtained by optimizing the threshold value. After that, region growing image is obtained, and in the feature extraction, area, circularity and aspect ratio is calculated. Then the optic disc is located and segmented the image. The graph is plotted using color histogram technique. Finally, we are classifying whether it is exudate or microaneurysm by using SVM classifier. First, the diabetic retinopathy occurs when it damages the tiny blood vessels inside the retina in the back of the eye. For the detection of microaneurysms and exudates, we are using SVM classifier. Diabetic retinopathy affects up to 80% of all patients who have diabetes for 10 years or more. Then the advantage of this process is computer-aided detection of exudates will give fast and precise diagnosis. The process time is faster in SVM classifier than other classifier. Here, median filter is better because it removes the noise and smoothens the images. Then finally, by concluding that the diameter of optic disc in the standard retinal image, connected components and iterative thresholding was used to locate optic disc. After that, by using SVM classifier, we successfully classified whether it is exudate or microaneurysms. This classification helps the ophthalmologist for diagnosing the retinal diseases. The process time is faster in SVM classifiers than other classifiers. Let us see the flow diagram for this process. First, pre-processing. Here we are getting green plane image, filtered image and compensated image. First, the input image is represented in green plane image. Then the green plane image reduce the effect of the intensity variation. Then the image is filtered using median filter for smoothening the image. After that, we get the compensated image by normalizing the green image. Then in reconstructed image, after the pre-processing method, we get the opened image. Then the transformed image is obtained by the difference between the input image and the opened image. Then the transformed image is reconstructed by geodesic dilation. The geodesic dilation involves two images, a marker and mask image. Then feature extraction. Here we are calculating area, circularity and aspect ratio. After the reconstruction process, we will get the threshold image by optimizing the threshold value. Region growing is done based on the image segmentation to partition the image. After that, region growing image is obtained, and in the feature extraction, area, circularity and aspect ratio is calculated. Then in segmented image, optic disc is located to detect the exudate. Then the image is segmented to detect the edges and boundaries. The image is segmented by using clustering technique. By using color histogram technique, graph is plotted. Then classification. Here we are classifying whether it is exudate or microaneurysm. Then the image is classified using SVM classifier whether it is exudate or microaneurysm. The classification helps the ophthalmologist in diagnosing the fundus images. A support vector machine is a discriminative classifier formally defined by a separating hyperplane. This is the flow for this process. Let us discuss the running procedure for this process. Here the main code is in fundus.m. Now I am running this file. Here the detection of microaneurysm and detection of exudates and classifications are in fundus.m. First, the detection of microaneurysm. Here first we have to load the input image from the datas. We can give any image from this datas, and all the images are in JPG form. Now I am selecting an image. Then the image is converted to green plane and filtering operations are taken for this image. Then compensated image. After that we are opening the image. This is the opened image. Then we get transform image. After that reconstructed the image again. Then threshold is taken for the image. After that the image is region growing for this process. This is the region growing image. Then feature extraction. In feature extraction we are calculating area, circularity and aspect ratio. Then detection of exudates. Here we are locating the optic disc. Then the image is segmented. After that this is the histogram graph for this process. Then we are moving to classification whether it is exudate or microaneurysm. But for this process, the image is microaneurysm.